Okay, so this is the first test of an infrared bounce array. So here we have 6 infrared detectors and 6 infrared emitters. And what I'm doing on this circuit board is I turn on each emitter, and then I go through each of the detectors and I say, how bright is that detector? And then I turn on the next emitter and I look at all the detectors and I turn on the next. So what we're looking here is all the arrays of output values from emitters to detectors. Bright, white means brighter. So, and the idea is that by looking at this assortment of outputs, of brightness, we can learn something about what is moving over these and how that's reflecting light. And we can learn something about where that is. So for example, if I'm very close, I would expect to be blocking a lot of the light that might bounce, say, from this emitter all the way over to this detector. So if I look on this emitter's graph, I only see things on the for a few of the detectors. And as I get further away, it's more sparse. One other thing I should mention here is I'm not modulating the light, which means I can't distinguish the infrared I'm putting out from the room infrared. And as you might expect, that's pretty horrible. So that's one reason we see a ton of noise in this graph. Modulating that is a more complicated circuit, not much more, but it's not what I built. And that would fix this problem. You can see it here too. So when I cover these guys up, really you only see the emitter lighting up the detector basically right next to it. And as I lift it up, I start lighting up more and more and more detectors. So the next part of the problem is looking at what we can learn about where an object is in 2D space over this array, just by looking at the input coming back in.